Hello students. So as a complement to the presentations that you've been making for our class, I've decided to make a little presentation myself. The topic of the presentation is going to be the one that you see on your screens right now. Are numbers real? This is an interesting and a big topic in the philosophy of mathematics, and let's go straight, without any further ado, into its discussion. I want to keep it short, no more than 15 minutes that you have constrained yourselves to adapt to in your presentations. Okay, so we shall start with two presuppositions that I think are necessary before we start debating or discussing if numbers can be real. So there are two presuppositions that I'm going to tell you that I would like to ask if you agree with them, and I suspect you do. So the first one is the nature of mathematics. So I assume, and I suppose you also agree with me, that mathematics is a science basically like any other science, at least like any of the other hard sciences. That is, it's a field of knowledge that tries to discover truths, and it studies basically objects, which are mathematical objects. It studies their properties and it studies their relations. This shouldn't be too different, as I said, from any other science. You can think of biology. So you could say that biology is a science that tries to discover truths about its area of knowledge. It studies objects, where biological objects would be living creatures like bacteria or plants or animals or cells. So those are biological objects. Biology studies their properties, so monocotyledonic or dicotyledonic plants, or aerobic or anaerobic bacteria, or eukaryote or prokaryote cells, and so on. And biology also studies their relations, like relations between predators and prey, or, different types of, commensalism, parasitism, and so on, and so on and so forth. So I think, just as this works for biology, I think you can say that it works for mathematics, and it probably would work for physics and for chemistry and for other disciplines. So first thing, mathematics is a science like any other science. It might have its peculiarities, but its basic working method, by studying objects, properties and relations of objects, is basically the same. The second presupposition that I would like you to think about and tell me if you agree or not is the following one. I think the truths of mathematics, though, do feel a little bit different from others. That is to say, in most of the sciences, truth is not completely absolute. Like you have the scientific method, which elaborates hypotheses based on evidence and then tests them and so on. But we basically assume, because sciences mostly have to use the induction, we basically assume that scientific truths are only temporarily true, like they are the best fit to the current theories and the current testable evidence. But scientific theories change with time. When more precise instruments of measurement or more effective theories that explain all the evidence appear, scientific truths get subsumed by a new scientific truth that includes most of the previous one, but probably goes into different ways. But in this sense, I would say mathematics is a bit different, because we feel that the truths of mathematics are a bit different from the truths of the physical sciences. Like, generally, truths in mathematics feel objectively and universally true, and in some cases even obvious. So the typical example is 2 plus 2 equals 4, which has been used as an example in literature, for example, in Orwell. So it seems clear that 2 plus 2 equals 4 is a truth of a different nature to the truth of there exists a God, or, which wouldn't be probably a scientific sort of truth, it would be a theological sort of truth, or like phlogiston is the material that makes things burn, which was a 16th, 17th century theory, now superseded by another one, which says that things burn because of the reactions of oxygen with certain materials. And that is true, but maybe the chemistry of 1,000 years from now will have a different system, which is not the atomic and the molecular system of matter. It seems unlikely, but it's not impossible. But clearly 2 plus 2 equals 4 will be true now. It was true 1,000 years ago. It will be true in the future. And it's true independently of time, of space, of culture, of gender, of anything. Most humans, I think all humans, would agree that this statement is true. Okay, so those are the two presuppositions that I present to you. Mathematics is a science that studies objects, and mathematical truths feel objectively true. Like they feel that they really have to be true, and that no historical or cultural or any other element can refute or change the truthfulness of mathematical truths. Okay, so having said this, let's go back to numbers and let's discuss if numbers are real. So numbers are a type of mathematical objects. There are other mathematical objects we could talk about, like sets or like geometric shapes or curves, whatever. But numbers are a very good example to discuss, because anything we could say about those mathematical objects, we can say about numbers. And numbers are a little bit more intuitive. Everybody is familiarized with numbers and how they basically work. So let's say the following thing. Let's ask the following question. What are the properties of numbers? So we saw that numbers are part of those mathematical objects which mathematics studies. What makes these objects mathematical objects? What makes numbers mathematical objects? So I would venture to say that there are three properties that numbers must have. Of course, this might be controversial, and we will be discussing the three properties and the consequences that arise from them. So the first property I would say is that mathematical objects, including numbers, have to be abstract. Now, I would venture to say that this should be a relatively non-controversial topic. I think everybody, or almost everybody, would agree with the statement that mathematical objects, that numbers, are abstract. It's not 100% agreed upon by philosophers. There's a case I mentioned at the bottom, Penelope Maddy, who disputes that mathematical objects are really abstract, at least some of them, and she tries to make a case for some types of sets. I haven't found her case compelling. And again, I think you, my listeners, would probably agree that mathematical objects are abstract. We could go into a little bit more detail and try to explain what we mean by abstract. So intuitively, when you think of abstract, you are contraposing it to concrete. So the idea is that something is abstract when it is not concrete, when it's not a specific instance of something or an object of something. It's more like the generalization, or perhaps the mental picture, the shared properties that certain objects have in common. So for example, when we think of beauty, so we may think of specific cases of beautiful people, but beauty as an abstract noun represents the concept, the abstract concept of beauty, that thing which all beautiful objects or beautiful people somehow contain in themselves, or that thing which serves to describe and put in common all those different objects and people who are beautiful. In philosophy, there's a more technical definition of what abstractness implies, and that description generally includes the idea that an abstract object is free from space and time. That is, an abstract object cannot change with the passage of time. It cannot be different by being located in different places. It doesn't live inside space-time like we do. It's outside of the space-time continuum. Also, it's independent from the laws of causality. That is, there is no power that could change, that could force, that could cause the number 4 to stop being the number 4. So numbers are independent of time and space, and they're independent of the laws of cause and effect. So as I said, I think this is pretty non-controversial. I think most of us would agree that numbers are abstract. The opposite view feels really counterintuitive, because if numbers are not abstract, that means they would have to be concrete. And if they have to be concrete, it means you should be able to point at number 1 or number 2 or number 10. And you don't find those things in the world. I mean, you find collections of objects that have 1 object or 2 or 10, but they're not the number 1. Like if I have one painting here and it's one painting, it has the property of oneness. Doing anything to the painting does not affect the number 1. If I destroy the painting, I haven't destroyed the number 1 either. So, it's difficult to think of numbers as not being abstract. Okay, the second property that I'm going to defend that numbers have is a little bit more controversial, which is numbers exist, which is the whole topic of this discussion. So do numbers exist? And as I said, this is more controversial, and here there are basically two positions really. There's the position that numbers exist, which is generally called realism or mathematical realism. There's the position that numbers don't exist, which is called nominalism. Now, this is philosophy, so there's no clear-cut evidence. There are arguments for and against each of the two theses, and each of the two theses has its good points and its bad points as well. So let's start with the realist position. Realists say that mathematical objects exist, and like almost everybody, they agree that mathematical objects are abstract. Now, this has some obvious advantages. From one perspective, it makes mathematics more like the other sciences, because the other sciences also study objects that exist. So it seems pretty intuitive, yeah? And it also avoids some truth and language problems, which we will comment when we talk about the opposite position, the nominalist position. But mathematical realism has a big problem, which is, okay, if we accept that mathematical objects, including numbers, are abstract, and we accept that they exist, an obvious question to ask is, where do they exist? Where are they? We said before that the fact that they're abstract means that they can't exist like in my bedroom or in some other remote planet of the galaxy. They have to exist in some sort of a place that is outside space and time and independent from the laws of causality. Now that seems something pretty difficult to stomach for any person of a scientific orientation in the 21st century, because it would imply the necessity of the existence of some realm which is outside the physical space-time in which we live in, which sounds awfully a lot like heaven or some sort of religious otherworldly place. And there's another big problem as well, which is if numbers are abstract and exist, how can we be in any contact with them? Because we said they're independent from the laws of causality and they live in a world that is separated from ours. How can we learn about them? How can we interact with them? So that is a big issue. So you would say, okay, the other position then probably makes more sense. The other position is called nominalism, and it assumes that numbers, like other abstract objects, do not exist. They might be a fiction or a creation of our minds, but they do not really exist. So this apparently seems to be making some intuitive sense. But, it implies that mathematics and the numbers are a fiction. More than that, it implies the following problem. We said before in the Prepositions that the truths of mathematics feel intuitively, universally, absolutely true. But if you adopt the nominalist position, you have to assume that mathematics is basically false. That is to say, when you say 2 plus 2 equals 4, and you analyze this statement logically, you would be forced to say, if you're a nominalist, that this statement is false. Why is it false? Because the number 2 does not exist, and the number 4 doesn't exist. So 2 plus 2 equals 4 is false. It doesn't exist. Basically, the idea of truth here is connected with existence, because generally we assume that things exist, and that we can only say true or false statements about things that do exist. Like if I tell you there is a creature called the blah 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 blah, which is an invisible pink unicorn, and it's smiling, and I ask you, is this statement true? This statement can only be true if that creature, the blah blah blah, exists. If it doesn't exist, then anything is possible. The statement could be true or could not be true. It depends on how I define the blah 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 blah. And anyway, even if I define it in a specific way, it would still be a false statement, because in the real material world, there do not exist those blah 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 creatures. So that's the problem that the biggest problem nominalists have. They need to accept that mathematics is a fiction, that mathematics is false, and that the statements of mathematics are false as well. They could be true in a certain way, like fiction. So, for example, we know that no hobbits exist, but in the fiction called The Lord of the Rings, it is true to say that there exist hobbits, or there exists a hobbit that is called Bilbo Baggins. But of course, this implies the consideration of mathematics as a fiction. So nominalists have to explain why a statement like 2 is a prime number is completely different from a statement like 2 is a green table, when those statements appear to be of the same type, and both statements appear to be objectively either true or false. In the case of the table, we can measure or check properties of the table. In the case of the prime numbers, we can't put the number 2 in under a microscope, but it feels true. Another problem that the nominalist position has is that if numbers are a fiction, like magic or like mythology, how can it be true that all of the hard sciences need mathematics and use mathematics for developing their scientific truths, for making predictions, for making discoveries? That is to say, mathematics is indispensable for the other sciences. If mathematics is a fiction, how can the other sciences not be a fiction as well, or not be false, since their main sustaining pillar, which is mathematics, is a fiction? Okay, let's move on then to the third and last property that I state mathematical objects have, which is independence. Now, when we had the previous debate between nominalists and realists about the existence of numbers, you might think that there could be a relatively easy cop-out out of this conundrum, which is to say, okay, let's say that numbers exist and are abstract, but let's say, okay, they don't exist in some remote, faraway world beyond the material realm. They live in our minds. Let's assume that even if they are not a complete fictional creation of our minds, they might be some sort of generalization of the patterns that existed in the universe before our arrival. So in this case, mathematics wouldn't exactly live in an outer world. They would be a generalization or but still some sort of a fiction created by our rational human minds to understand and interpret a physical world, and probably connect to that physical world, and that those regularities of the world appear in the regularities and in the axioms of mathematics. So, okay, this point of view seems to be, okay, pretty commonsensical, and it seems to work. Like if you think of numbers, simple numbers like 1, 2, or 3, you can imagine how perhaps our remote ancestors saw groups of 3 objects which exist in the world, and from counting them and grouping them, they abstracted a notion of threeness, a property of threeness that is not that different from the property of beauty or intelligence or any other abstract humanly made logical concept. The problem is, there are some numbers that are pretty weird and that are not really encountered in the physical world. Typical examples would be pi, which is an irrational number, as you know, with a never-ending decimal expansion, which does not really exist in the physical world. I mean, pi is the ratio of a circumference of a circle to its diameter, and you can measure and calculate ratios of circumferences to diameters in circles in the real world, but you never get pi. You get an approximation of pi, like 3.1 or 3.14. There is a limit to how accurately and precisely you can measure, whereas pi by definition is unmeasurable in the sense that it is infinite. It's not 3.14, it's an infinite string of non-repeating decimals. And there are even weirder numbers like the imaginary unit, I, that is the number that when squared is equal to -1, which does not make sense for any type of real numbers that we are used to working with. Or quaternions or octonions. Those are numbers that don't seem to exist in the real world, and yet they exist in the mathematical world. They don't seem to be extrapolations from the physical world either. And anyway, this cop-out also has the same problem really as the nominalist point of view, because it's a watered-down version of the nominalist point of view, and it's exposed to the same questions. That is, if numbers are ultimately something that we create in the mind, a human construction like poetry or language, how come the physical world is mapped, predicted, described so well by numbers? You would have to say, if you assume that numbers are just a creation of the human mind, that our perceptions of the world, our predictions of the world, everything we build with science about the world is also a fiction of sorts. It's some sort of fantasy or fake creation of the human mind. So I would say that this is not the case. I would say that the third property of mathematical objects, besides existence and abstractness, is their independence. That is, numbers and their truths would still be there if humans or other rational beings had never existed. If a meteorite had killed all our mammalian ancestors, my point of view is that it would still be true that 2 plus 2 equals 4, even though there would be no humans to, to think about it. And 2 would still be a prime number. That is to say, those things would not change just by the fact that no humans developed intelligence and started thinking about mathematics as an area of knowledge. So, in conclusion, are numbers discovered? Are numbers invented? So, my point of view is pretty clear. I would say that accepting those 3 properties that I mentioned above, abstractness, existence, and independence, that would make you what is generally called a mathematical Platonist. And it's a controversial point of view. I've shown that all of those 3 properties, especially the second one, but all of them can be disputed. As I said, this is a philosophical, not a mathematical stance, although the majority of practicing mathematicians are really Platonists and act as if the truths of Platonism, of mathematical Platonism, were real. That is, they generally assume that mathematics is not just invented by them, it's discovered through the mind, but discovered. And personally, I am a very strong mathematical Platonist, and even though I don't like some of its implications, so the idea that there exists a non-material realm where the numbers are prancing around, I find that very hard to believe. But I must say that I like the implications of rejecting any of these 3 properties even more. So that's how I stand on the issue. Tell us what you think in the comments.